Assalamualaikum to my lecturer. My name is Sida Aisha, matric number S75914. Today I will present my individual assignment for ACT 3513 Accounting Information System. For the assignment, I will demonstrate how I develop a relational database using Microsoft Access and created queries to solve the question given in problem 4.10. So first, I will begin my opening Microsoft Access and creating a new blank database. As we can see here, I am creating the database file for this assignment. The purpose of this database is to store information related to borrower, lenders, and appraisers. These tables are connected through relationship which allow the data to work together efficiently inside the system. Now, I will start creating the first table, which is the borrowers table. Inside this table, I will create the required fields such as borrower ID, last name, first name, then the ID, appraiser ID, and requested mortgage amount. For each field, I need to assign suitable data types to ensure the database functions correctly. For example, borrower ID will be used as the primary key because every borrower must have a unique identifier. The requested mortgage amount field, we use the currency data type because it stores financial information. After completing the borrower table, I will save the table before continuing with the next table. Next, I will create the lenders table. This table stores information related to lenders, including lender ID and lender name. Lender ID will become the primary key because it uniquely identifies each lender. Now I will continue by creating the appraisers table. This table contains appraiser ID and appraiser name. Again, appraiser ID is selected as the primary key to ensure every appraiser has a unique identifier. After creating all tables, I will proceed with data entry using the information provided in the assignment question. Since entering all data manually takes time, some parts may be fast-forwarded during the video. However, all important processes are still clearly shown for demonstration purpose. Now that the data has been entered, I will move to the relationship section. Under Database tool, I will open Relationship and add all the tables into the Relationship window. Now I will continue with which is query development. In this section, I will create and explain queries A until F based on the assignment requirements. For each query, I will demonstrate the SQL view, design view, and datasheet view output. I will start with query A. The first question asks, which borrower used Advanced Appraiser? The required output is borrower ID, last name, and appraiser name. To answer this question, I first create a new query using query design. Then I add the borrower's table and the appraiser table. These two tables are connected using appraiser's ID. Next, I select the required field, which are borrower ID, last name, and appraiser name. Under the criteria section for appraiser name, I type Advanced Appraisers. After running the query, the datasheet view display all borrowers who use Advanced Appraiser. Now I will open SQL View. Here we can see the select statement, inner join statement, and read condition used in the query. This query demonstrates how data from multiple tables can be combined using relationship. Next, I will continue with query B. The second question asks, list all property appraiser with the letter D in the name sorted by name. The required output is appraiser ID and appraiser name. For this query, I use the appraiser table. I select appraiser ID and appraiser name. Then under the criteria section, I use the like operator with wildcard symbol to search for appraiser name containing the letter D. Next, I sort the appraiser name field in ascending order. After running the query, the datasheet view display of matching appraisers sorted alphabetically. In SQL View, we can see the like condition and order by statement. This query demonstrates filtering and sorting function in Microsoft Access. Now I will move to query C. The third question asks, list all lenders who participate in a transaction that use appraiser ID 8. The required output is lender name, borrower ID, and requested mortgage amount. To answer this question, I add the borrowers table and lenders table into query design. The tables are connected using lender ID. Then I select the required field. Under the criteria section for appraiser ID, I enter the value 8. After running the query, the datasheet view displays all lenders involved in transaction using appraiser ID 8. In SQL View, we can see how the tables are joined together using inner join. This query demonstrates how relationships allow information to be retrieved across different tables. Next is query D. The fourth question asks, list lenders that lend more than $100,000. The required output is lender name and appraiser name, and each combination should appear only once. For this query, I use the borrowers, lender, and appraiser table. I select lender name and appraiser name. Then, under the requested mortgage amount field, I enter the criteria greater than 100,000. To avoid duplicate result, I use the distinct keyword in SQL View. After running the query, the datasheet view display all the unique combination of lender name and appraiser name. This query demonstrates filtering high-value transactions and removing duplicate records. Now I will continue with query E. The fifth question asks, what is the average amount borrowed for each lender? The required output is lender ID, lender name, and average mortgage amount. The result must also be sorted in descending order. To answer this question, I use the borrowers table together with the lenders table. First, I add the required field, which are lender ID and lender name. Next, I use the average function to calculate the average mortgage amount. I also use the round function to display the value with 2 decimal places. Then I group the record based on lender ID and lender name. Finally, I sort the average mortgage amount from highest to lowest. After running the query, the datasheet view displays the average amount borrowed from each lender. This query demonstrates the use of aggregate function, grouping, and sorting in Microsoft Access. Finally, I will explain query F. The sixth question asks, how many appraisals did each appraiser perform? The required output is appraiser name and count of appraisers. For this query, I use the appraiser table together with the borrowers table. The tables are connected using appraiser ID. Then, I select the appraiser name and use the count function to count the number of appraisals performed by each appraiser. Next, I group the record by appraiser name. After running the query, the datasheet view displays the total number of appraisals completed by each appraiser. This query demonstrates how aggregate function can summarize business activity and performance data. After completing all 6 queries, I review each output to ensure accuracy and confirm that all assignment requirements were fulfilled. Throughout this assignment, I learned how relational database function inside accounting information system. I also improved my understanding of primary key, foreign key, relationship normalization principle, and SQL query development. In addition, this assignment strengthened my skill in using Microsoft Excel for database management and problem solving. Overall, relational databases are very important because they help organizations manage data efficiently, reduce redundancy, and produce meaningful information for decision-making purposes. In conclusion, I successfully developed a relational database in Microsoft Excel, created relationship between tables, entered the required data, and developed queries to answer all questions from problem 4.10. This assignment helped improve both my technical knowledge and digital skill in accounting information system. Thank you for listening to my presentation. That is all from me.